Welcome, everybody. Thanks for coming to this event today. This is a long time in the coming. I'm John Manwaring with Learning Innovations and Creative Corridor, and partner to many of you. Before we begin, I wanted to have us remember that Washington State University Pullman campus is located on the homelands of the Nimiipuu Nez Perce tribe and the Palouse people. We acknowledge their presence here since time immemorial and recognize their continuing connection to the land, to the water, and to their ancestors. I'm excited for this opportunity and the many opportunities that are available to us. This is only the second week of campus operations here, fall semester. There's a lot of different events that are available to all of us, and I would invite you to take advantage of all of those, including in the Fine Arts building next to the Art Department office. There is a juried show that is up now. It's called In Solidarity. It's right, like I said, it's right next to the Art Department office. It's a regional juried exhibition featuring works on the themes of community, identity, and social justice, and it closes on September 14th. So please find some time to stop by and take a look at that. It's a wonderful show. I wanted to thank the many people who've made this event possible. This is truly a collaborative effort, mostly led by Hallie Meredith, who, without your energy, I don't know where we would be with this. So you harnessed the energy here, so appreciate that, Hallie. I wanted to also include the College of Arts and Sciences, the Common Reading Program, the Art Department, the Jordan Schnitzer Museum of Art for hosting us as well, the Global Campus, the David G. Pullart Center for Arts and Humanities, the International Year of Glass 2022, and the Creative Corridor. This is truly a team effort to make something like this happen on the campus, and just a wonderful opportunity for students and the community to partake in. I wanted to just take a moment to talk about the partnership between Creative Corridor and Hallie. Hallie's energy is endless, and that's exactly what we need. We're hoping not to use her up, but we will keep working with her until the wheels fall off. When we first started talking about this, I believe last year, we had an opportunity to explore some different things about what she was wanting to pursue with the technology of glass. So we had some of our team members work with Hallie on creating an app. With Mary Packer, we created some 3D renderings of historical artifacts that are available up here, and I'm sure Hallie will discuss that. Those have been manifested both in virtual reality as well as some physical reality here with 3D printing. But it's really been a journey, an interesting exploration, and a great way for technologists to partner with faculty to explore content for class as well as research. And I would invite any of you who'd like to do likewise to meet up with any of our team members with Creative Corridor, which is a transdisciplinary effort and present across the campus. With that, I would just like to introduce Hallie Meredith. Hallie is an assistant professor of art history in the Department of Art at Washington State University here in Pullman. She specializes in antique work, craft production, Eurasian exchange, and ancient technologies with a glass emphasis. In addition to editing and co-editing publications on late Roman visual culture, she is the author of World Becomes Image, Open Work Vessels as a Reflection of Late Antique Transformation. Dr. Meredith is also writing a forthcoming book entitled The Unknown Artist, Anonymous Roman Glass Artisans and Their Legacy, which considers the communities of late Roman craft workers as a history for today's craft community. And with that, I will turn it over to you, Hallie.
Thank you so much, everyone who's here. I really appreciate it. This has been a joy to come to fruition, to have this manifest. So I'm going to start with probably my most important slide, and that's the acknowledgements, the thank yous. So I won't read this list because John mentioned some of the institutions and people already, but this is a very small percentage of the number of people who contributed to this, and I'm really, really grateful. Okay, so I would like to start. So it was already mentioned that I teach classical and late antique art and archaeology here on the Pullman campus. Before earning my doctorate, by chance, I took a glassblowing elective. And from the start, I loved the intensity of working start to finish on a piece, because you can't put the glass down, as you'll see shortly. Working with an assistant, because typically today you work with someone else, and it's really a collaborative process. And then maybe most important in all of this collaboration is working with the glass. I was never a great glass blower. I didn't just study it for years and years, but I was good enough to know that the glass was a partner that could direct me and that we could work together. And so from the beginning, I was hooked, and I'm clearly not alone in my response to glass, nor am I the first WSU professor in the Department of Art to feel this way. George Leisner was born in what was then known as Czechoslovakia. He was a well-known WSU artist and art professor who taught in Pullman from 1937 and for nearly 40 years. During his career, he received honors for his work in areas that included ceramics, etching, glass, lithography, painting, and sculpture. But in his work as a glassblower, it is this work that is featured in these two images. One, the retrospective piece on the right, and then on the left, this is the little plaque, which is just outside the Department of Art quad, which I can show you if you haven't seen it yet. And this is part of what got me really interested in the glass on the campus here in Pullman. So during my talk, I'm going to show some of what I find so fascinating about the process of working in hot glass. And I will introduce you to an interactive app that I designed in collaboration with Mary Packer to help you share in the experience for yourself. And so my talk has two goals. The first aim is to explain why the ancient Romans. So what do the ancient Romans in particular have to do with contemporary glassblowing? They remain closely entwined, and as I will demonstrate, very little has changed in the 2 millennia since glassblowing was invented. My second aim is to show the connections between my historic introduction and the glassblowing demonstrations that you will see later today. Okay, so we start with this piece. And it's the same piece you can see on the right. It's a lamp, so it's a small clay lamp, and then just a detail on the left. And this is one of the best preserved images of glassblowers from antiquity. It's a 1st century lamp. It's a clay lamp. But what you can see here, and let's see, try it this way. Okay, what you see here, this part is where you would light the wick. And this essentially would frame the image of the glassblowers. So it's a really clever design in that they use the illumination to actually light the furnace that would have then itself been heated. Another image, again, one of maybe only two that survives from antiquity, is this one. So on the left, we have a sarcophagus, and it's from the maybe 2nd to 3rd centuries in Aphrodisias in Turkey. And what you see is really clearly, this is the whole of the tomb. This small detail that you see here are the two makers at a furnace. Most likely they're glassblowers. It could also, it's been argued that maybe there's some bronze smiths or something else. But it seems pretty clear that they're pyrotechnical, they're working at pyrotechnics. And so here, what you notice is that you have these two large-scale figures, a large, lengthy inscription, and it's all about them. For some odd reason, we have these glassblowers, and it's not explained why they're there or anything about them, their relationship to the two main figures. So in both of these examples, again, really the only two images that we have of what glassblowing was even like in antiquity, we have this kind of peripheral, right? It's a secondary position for the glassmakers, and whatever their connection is, we don't know, to these main figures. And then this scene, which is, it's a decoration for a lamp, right? So it's kind of secondary and decorative. And so, again, the presence of these glassblowers, they're rarely studied in and of themselves. But this is, as it was mentioned, really a strong interest of mine and the focus of my monograph that I'm working on. And so, again, connecting this ancient tradition to the present, as you can see in this comparison, there's very little that's changed since antiquity and what we will see later today with contemporary glassblowing. Apart from electricity, obviously, the tools are the same. People need to be trained in actually making the furnace and then remaking the furnace and maintaining it. And so as you can see here on the left, this is a glassblower from Murano which ever since about the 1290s, that's where they kicked off the glassmakers in Venice, right, to this island, so that when they burned things down, it would be all limited to one space. But as you can see, we have here, there's the main figure who's the primary, maybe he's the only glassblower, it's not really clear, again, what they did in antiquity, but he's larger in scale, he's got the really long blowpipe with a large piece on the end, and then here you have an attendant figure, you can see he's tending to the furnace, making certain that it stays heated. Here you also have the glassblower, he's got the same blowpipe, a long, large piece, here's where you clean your pipe, so really it's the same basic setup. And then the thing I find really fascinating is the furnace construction. So again, this is the only image that we have that survives of what the furnaces actually look like. And you can see they have a broken pot, which acts like a door. Here you have the glowing furnace. And so this, again, the same basic setup. Today, we obviously know a lot more about glass blowing. And so in this example, you have an artist. This is Atsuko Ishikawa. And she had a show in this space not long ago. And she started off as one of Dale Chihuli's assistants. She has had a long and fantastic career. I think she's retired recently. But what you're seeing here is a different way of working with glass. And again, because we have more biographic information today, you can see that she's using the blowpipe as a drawing tool. And I'm not capable, oh, there we are. So as she's using it as a drawing tool. And so this is a very long piece of paper, and she's heating using the end of the blowpipe to actually make a drawing. And you can see down here one of her pieces, this is vitrified 3818, where she's added watercolor and on the paper. So just really stunning works. And again, now what we understand to be glass is really, it's transformed. It's not one thing, it's kind of everything. And so this is part of why I'm so fascinated by this material and the people who make these objects. And so again, this is why I'm talking about the ancient Romans and their importance to glassblowing today and to glass in general and just art in general. So I'll shift now to my second objective. And this is about connections between my historic introduction and then the glassblowing demonstrations that we'll see later today. And again, part of my aim was really to give you the opportunity to, like I had, of becoming addicted to glass by doing something more interactive with it. So you'll get the chance to see the glassblowers, which is extraordinary, but to help you to ask maybe more in-depth questions and have more of a sense of agency in terms of your investigation. I developed this app with Mary, and it looks like this. Thank you. And so I'll show you briefly. I'll show you now just really briefly the opening slide to the app so you get a sense of what it's like. And I'm going to give you some context. Great, thank you. Okay, so when you open the app, you can see that you're going to navigate to this page. It's all interactive, and so if you want to find out more about any of these pieces, then you can click on them, and then we'll have QR codes available. So again, you can it's all web-based, so it'll be pretty straightforward. I won't duplicate what's here, and Rob, if you don't mind putting me back. But what I'm going to do is give you some context for what you're going to see in the app. Thank you. Okay, so we'll start off, we'll go chronologically. This is an example of a bird, as you can see, a bird form. It's a blown piece, and it's a really elegant, kind of minimalist example of this shaping, and you can see the size and all of that, but it was a perfume bottle. So a lot of what survives this is actually a pretty inexpensive object. I say inexpensive because what they did was they filled it with perfume, so presumably they were the glass makers and then the perfume makers working together, and then they filled the bottle with the perfume, and then you would break off the end. So it's all hollow because it was made of a bubble, because glass always starts with blown glass starts with a bubble. But they filled it with perfume, and then people would remove the end to use the contents, and then they would throw it away. And the reason why I imagine this is probably an inexpensive piece is because about 40% of the rubbish that you find in Rome in recent excavations are these kinds of objects, so perfume bottles. So they seem to have been single use and just thrown away after that. There's a lot of continuity. So again, glassblowers today still look back to the past. And this is a work by a very well-known Milanese artist, Lino Tagliapietra. This is his Phoenix or Fenice. And you can see similarities between the forms. Obviously, he has a very complex color structure, right, with the canes, and we can talk more about that later if you're interested. But you can also see some of the connections, the clear connections. We'll turn now to an example of what's called a write-on. And this is, you can see these different views. You can also see how here, this is a place where presumably you could hold it and it wouldn't slip out of your hands. It's a drinking vessel. This is one example from Pompeii. These are a couple of examples from Corning and then from Israel. And you can see they varied quite a lot. In this example, they both have the same kind of antlers and then an open spout, so you could drink the contents. And when you look at examples from Pompeian wall frescoes, you can see these gods. So this is probably Venus and Mars. You can see the gods themselves drink with these vessels. Here is a really well-known example which tells us what the function was. This is from the House of the Drinking Contest. And you can see you've got Hercules and Dionysus asking for more drink. And so you've got two versions of these. And you can, again, see the same basic idea. You're supposed to fill it and then drink the contents in one go. And so we'll shift to this piece. And this is the object that we have the 3D versions on the table. And you're welcome to handle them and see what they're like, because they're really quite astonishing that way. I wrote a book about these objects. I'm fascinated by them, so if you want to talk about them more later, I'm very happy to. They're known as open-work vessels, or they're also called diatrata, or cage cups when they're made of glass. And you can see they have a lot of really different kinds of imagery. The early ones were made entirely with images. Later, they have inscriptions. Here, on the left, you have masks and columns. Here you can see an inscription. And then this is one of the wonders of the ancient world. It's the Lighthouse of Alexandria. And so these are some examples. It's thought that they, after 2 centuries of debate about how they were made, it's actually thought that they were carved completely. So you take a very thick piece of glass, and as we'll see outside, when you dry glass, it's called annealing, so that the interior and exterior temperatures aren't too different, so that they can the vessel can dry slowly and not crack because of stress fractures. But with a thick piece of glass, that's really hard to dry in a controlled way before electricity. And so it's an interesting problem about how you have such a thick piece of glass, what that means for the process of production. But basically, the important part is you carve into this thick piece to make an inside to the outside. So you're actually creating 2 layers, and they're connected by these horizontal glass bridges when it's made entirely of glass. They're really striking works. And some of the most important pieces are the broken ones. So this is something that I think is really interesting about archaeology. When you go to museums, you rarely see the most important pieces on display, because often they're the fractured, broken ones that the public might not be as interested in. But in this case, this is a piece in the Met. It actually changes color. The glass changes color, and I'll talk about that in a minute. But you can see, when you see it, you have evidence of the carving. So again, the broken part means that you can actually see more about how it was made than you could otherwise. A couple more examples. And you can see, again, the inscription. And then these 2 are lamps. And they're extraordinary, right? So this is really high-end carving. And I argue probably not just done by glass carvers, but people who were engraving in a number of materials. So there's an interesting question about the communities of makers and how they interacted. And then this piece is, and I think we're going to leave it like that. This piece is the one that changes colors. There's a very small amount of gold and silver in the fabric, and that's what allowed the color changing property to occur. And when you see it in the museum, they actually have it light changing, so you can see the color change. And there's a text that talks about a piece made of rock crystal from the 2nd century. And in that one, that piece, it talks about the color of unripe grapes changing to the color of ripe grapes. So again, think about drinking wine and having the kind of magic trick of adding wine, and then suddenly the glass changes color. And so hopefully we'll hear more about this when we hear John McCloy's talk. So just a few more pieces here. This is an example of a container. And this was probably used for makeup or lead or something to maybe like a version of sunscreen for your eyes. And so this is a long dipstick that would allow you to take the contents and use them. And there are a number of these multiple chamber objects which survive. This is one in Colorado, and you can see it's fairly plain. and then here a much more ornate one in Brooklyn, and again several survive usually from around the 4th to 6th centuries. And then here is an example of a really interesting kind of early Islamic vessel, and this is, as you can see, it's a camel. They come in other versions, and you'll see them on the app. And so in this piece, what is obviously most visible is you have the vessel here, the camel form as a base, and then you have this. And this is actually, it's the protective basketry that was used on the Silk Road. And so it's a version of what you would see in real life. And so here are more examples of basketry. Right, so these represent secondary industries where you would have not only the object, but then also the people who produce the packing materials. Similarly, you get packing materials that are part of the process of pouring and other ceremonies and occasions. And so you can see that here. This is a transport vessel, and you can tell because it's square. So it's obviously not as likely to fall and move on a ship, for example, as a circular one would. And you can see that even though this is a mosaic version, and obviously they didn't have to have a lifelike version or from reality, they actually have something which is quite similar to vessels that exist. Right? And this is a piece from Pompeii, which again looks pretty similar to this vessel. And so as I conclude, what you have here is yet another step on the tour on campus that I would suggest if you're interested in finding out more about glass. This is not my first partnership with the museum. I've been fortunate to work with them in the past. And there's a really interesting representative collection in the Q, or the Smith Center. And so I worked in 2016 with some undergraduates for my first year here. I was really excited to find not just George Leisner, but also the glass, the large amount of glass that's here. And so the undergraduates that I worked with, they put together some research that they wrote up, and the museum generously had it on the website until just last week, I think. But it was there for a long time, and so it was a great partnership and a way for the students to really get something out of that experience and have this kind of public presentation and publication. So I'm really grateful to all the people involved, and I would encourage you to have a look at the website, to play around with it. If you've got questions about it, or if you want to talk about any of the pieces, I'm happy to do that as well. And just, I would suggest that later when you're seeing some of the work that's being made and the way that people are approaching thinking about making, think about antiquity as well, and the kinds of questions that come up by looking at these pieces, thinking about how you could make them. That's kind of my goal for the whole project, and why we've got the glass blowers here, is to think about making and what the different ways that it's possible, what could have changed the way that you might make something today or in the past. Again, relationships with other makers, the kinds of questions that you have, these are all go into all of this. And I think I will end it there. Thank you.
Okay, so now for something completely different. My name is John McCloy. I'm a professor in the School of Mechanical and Materials Engineering here at WSU. And I'm going to tell you a little bit about glass from my perspective. And I thought, given the fact that this is in an art museum, I would talk a little bit about the history of glass. And so what I'm going to do is I'm going to start at the present, and I'm going to go all the way back to the beginning, and then we'll end up back at the present. So because I am an engineer, I thought I would be remiss if I didn't actually tell you a little bit about the science of glass. So I will have a couple of science segues in here for you. So we're going to start with what is glass, because we haven't actually answered this question yet. So from my perspective, what is glass? Okay, we're having an issue here. There we go. In the words of one of my colleagues, glass is a non-equilibrium, non-crystalline state of matter that appears solid on a short time scale, but continuously relaxes towards a liquid state. Okay. I'm not going to belabor this definition right now, but I'll keep that in mind, and we'll return to that later when we talk about cathedral glass. But you know, a word about crystalline and non-crystalline materials. So a crystalline material has a regular arrangement of atoms, and a non-crystalline one has an irregular arrangement of atoms. And one of the reasons that glass has the properties that it does is because it's non-crystalline. Okay. So glass is so much more than this, though. And this talk and a little bit about my experience in glass is a little bit like a joke that I won't tell you, where an engineer, a volcanologist, and an archaeologist went into a bar and talked about glass. But because we started this because of this event called the International Year of Glass, I'm not going to read all this, but I wanted to tell you what it is. Okay, so the International Year of Glass was proposed by people all over the world, including some of my colleagues, to the United Nations. And then it was officially recognized, and there were a whole bunch of celebrations all over the world last year, lots of special events. And this text here, and I'll just highlight some of the things. Basically, they have to make an argument to the United Nations that we should celebrate a particular thing in a given year. And so, for example, the argument here, in addition to the importance of glass in art, today in our lives, we need glass to hold medicines. If any of you have severe allergies, if you didn't have glass vessels, you couldn't have EpiPens. We wouldn't have the World Wide Web. All of our web pages and everything else are carried on optical fibers made of silica glass. Okay, our space telescopes are composed of glass mirrors with metal on them. Okay. Recycling of glass is actually perhaps one of the oldest materials that we've ever recycled. Okay, so these are very important things today that I'll go into a little bit more at the end. But glass had arguably some humble beginnings. There's an imitation of nature in art. This is an ocotillo, which if you've ever been to Arizona, they're everywhere. This is actually a Chihuly piece in Columbus, Ohio, of what I think is an ocotillo. And so there's some maybe associations that we might have with glass in the past, which maybe these things were ephemeral, they're one-time use, like Dr. Meredith said, you just throw them away. Maybe they're fragile. Whereas today, at least when I think about glass, it's extremely high-tech. Every one of you has at least 3 pieces of glass in your pocket. Okay, there's at least 3 panes of high-tech glass in every cell phone, and all of these displays, etc. And I would argue that it is everywhere now. Okay, so it is ubiquitous, whereas it used to be a very specific luxury good, as I'll mention. But I want to read a couple of quotes to you by a man named Cyril Smith, who, if you're interested later, I can tell you about him. He's a fascinating person. But he wrote in 1981 some things about the relationship between scientists and engineers and artists. And he said, it is misleading to divide human action into art, science, or technology, for the artist has something of the scientist in him and the engineer of both. And okay? Nearly everyone believes falsely that technology is applied science. Technology is more closely related to art than science, because the technologist, like the artist, must work with many unanalyzable complexities. I can tell you this is absolutely true if you talk to people in industry. They always figure stuff out, but they don't know why. Okay, and this is how glass artists began using the material. And historically, the very first discovery of useful materials, machines, or processes has almost always been in the decorative arts and was not done for the perceived practical purpose. Necessity is not the mother of invention, only of improvement. Okay, so whenever I talk about glass to any of my classes, I always start with this. Okay, and so it's an important thing to recognize the relationship between art and science. So the question of origins is always one that's interesting to think about, and especially as a materials scientist, I wonder about this. And so a lot of people have written about how people discovered glass making. You know, some of the things that have been talked about, you know, there are slags that are created when you do metalworking, and slags generally are a glassy type material with some silica, and this is just because of the minerals that metals, when we extract them from the earth, have in them. You tend to make a glassy material. There are also natural glasses. I'm sure you're familiar with things like obsidian, but there's also some more exotic ones like this. This is called Libyan desert glass. It's produced from the impact of a meteor many millions of years ago. And this was known in ancient times because it's used in some things that we found in Tutankhamun's tomb. So people were familiar with glass, and it has different character than other materials, the way it breaks and so forth. Early on, there was actually some investigation of faience, and some of you may have heard of faience. It's not exactly glass. It's really a reaction product on the outside. It's not a bulk material, but it does have some similarities to glass making. The first glass that we know of are actually beads, and these are from about 2500 to 1500 BC. And they are designed to look like rocks. So this maybe seems a little bit backwards, right? But precious stones, for example, lapis lazuli, turquoise, some of these other highly desirable stones for jewelry were copied, essentially, in this medium. Okay, and so these are the first materials that we have. So here again, imitating nature. So how is glass made? What is it made of? Well, there's mainly three components to most glass. Now, I should say that, which I'm not going to talk about, but you can make just about anything into a non-crystalline material, which we could call a glass. But I'm specifically talking about what we commonly understand as being glass, which is soda lime silicate glass. Okay? This is not some of the other technological glasses that I'll say about later, but so sand is one component, and then you have to have an alkali component. And so over historical time, there were two different materials that were used for the alkali component. The first one was burnt plants. And so there are several types of plants. This one happens to be still called glasswort, which means a medicinal plant used to make glass. And so these are salt-loving plants, so they accumulate alkali in their tissues, and then they're burned, and then you use the ash to add to sand, and I'll explain why you have to do that later. The other one that was really used in Roman times is called natron, and natron comes from the word or the name of a place called the Wadi Natrun, which is essentially a dry riverbed in Egypt. And this is natron. It looks like these big cakes. But it's essentially a salt mineral, an evaporate mineral. So when the rain comes down and dissolves the minerals in the place, and then it evaporates again. So gypsum is another example of an evaporate mineral. In Egyptian times, they used natron to mummify their dead, which you may have heard of. But they did not use it for glass making, interestingly enough. They used plant ash. And then there's also another component that you add, and that's lime, which can come from limestone or shells or something like that. And we have evidence that that was not really added deliberately early on, that it actually came from the container, which I won't get into right now unless you ask me a question about it. but later it's added and it makes it more chemically durable. Makes the glass easier and more permanent. And then over time, of course, you add all kinds of things to make it colorful or to remove color and to add different textures and so forth, like you've seen. So I want to talk a little bit about the technology here, as you know, you're going to see that later. So pyrotechnology being how we heat materials and how we process them. And depending on whether you think in Celsius or Fahrenheit, I put them both here. So the first thing to recognize is that, you know, okay, so my household oven goes to about 450 degrees, right, Fahrenheit. A campfire, you can get up to 900 degrees Celsius. And in order to do certain things, which I'll say in a minute, you need what's called a drafted furnace. That means that you have to have air coming through it. So you either have to have a bellows or some kind of way of forcing air to get to 2200 degrees Fahrenheit or 1200 degrees C. And that's with the typical fuels that would have been available, like wood, dung, straw, etc. So the earliest metals, you could almost make bronze in a campfire. Not quite, but to get to wrought iron, which is, you know, iron that you have to actually beat it to make a solid material. It becomes very porous, and then you have to beat on it. Or cast iron is very high temperature, so that was not achieved in ancient times. Things like pottery, you know, again, we're getting close for some earthenware, you know, not quite campfires, but you have to do a little bit more work than that to have a kiln. For some of the higher fired potteries like porcelain, you know, very high temperatures that you couldn't achieve without special technology. Now, glazing, which you're maybe familiar with if you're an artist, you know, you might put a glaze on the outside of a pot, and that's either for decorative reasons or also for preventing water from leaking out. The earliest glazes were lead-based glazes, and so those melt at very low temperatures. So you could actually do that on a campfire. However, if you take pure sand, it's off the charts. You can't melt it, okay? So if you hear these stories about people discovering glass because they left something on their campfire too long, that's just wrong, okay? However, if you add a lot of soda to it, then you can drastically reduce the melting temperature. And so that's why this combination of soda and sand is so important. So what you'll see outside are these temperatures. So an ideal blowing temperature might be around 1200 degrees C. And the glory hole, which is where they're gathering the glass from it, somewhere between maybe 15 and 1800 degrees C. Okay? So calibrating you there with that. Okay, so that said, in order to have glass, I have to have draft furnaces, and I have to know something about glazing. And so the most convincing arguments that I've heard about the origins of glass has to do with the sort of confluence of the peoples that knew how to do ironworking and the peoples that knew how to do glazing. And so that would have happened roughly 2500 BC with these people called the Hurrians that lived in the mountains of Anatolia, and the Akkadians who lived in the Tigris-Euphrates river valley. And so this map just shows that there was some conflict between these peoples at this time. And so the first evidence that we have of Mesopotamian glass is around 2400 BC, whereas for Egyptian glass, it's like 1,000 years later. Okay. We're going to talk a little bit about Amarna. This book is actually a really fascinating book. This man argues that it was actually the Semitic people who took the knowledge of glassmaking throughout the ancient world and didn't actually teach anyone else, but they imported these people that knew what they were doing. So a little bit about Egypt. So these are pictures that I took in the Corning Museum of Glass. If you didn't know that was glass, you would tell me it was stone. Okay? These are all glass pieces, but because they are so old, they've actually corroded. Okay, you don't normally think of glass, you think of metal as corroding, but glass corrodes too. It just takes a really long time. And if you see some old vessels and they're all different colors and silvery, that's actually not what the glass looked like. That's the corrosion product on the glass. Okay. So the vessels at the time, maybe looked something more like these. The two important sites in Egypt that we know the most about are Amarna, which is down here in the Upper Nile, and Qantir, which is down here in the Upper Nile. Okay, and so the interesting thing about this is that they were specializing for color, and so in Amarna they were making blue glass using cobalt, and in Qantir they were making red glass. And again, if you saw this, you wouldn't think this was red glass. It's all corroded, but when you cut on the inside, you can see that it was red. Okay, they were making that with copper. Now, we can tell from some chemical analyses that there are other blue glasses that are around. We know that there's some blue glass that's colored by copper that's coming from Mesopotamia at this time. So what archaeologists are interested in, and what this map is showing, is that there are all these trade routes that are happening in the ancient world, and we can trace them using different materials, but glass as well, based on the chemistry. So a little bit more about how glass was made during Egyptian times. It was actually, this is where there's really a specialization difference. And so you've heard a lot about what I call glass working. In the ancient times, there were separate professions. You had people that made the glass and then people that worked on the glass. I would be somebody that makes the glass. These people out here work on the glass. So they make the vessels, I make the raw material. So we have evidence that this glass raw material was made even 1500 BC in these cakes, and we found these ingots in shipwrecks off of Turkey in the late Bronze Age, and we have evidence from Egyptian tombs that these were provided as gifts to pharaohs, and they were most likely confined to what are called the Syrians, which some people believe are the Semitic people. And so, the production was happening in Egypt during this time. We know there was no production in Crete, and it's unclear about Mesopotamia, but all the distribution was based on gifting between these rulers, okay, because the production was very centralized. In a later period, we have important people like King Ashurbanipal, who gives us the first written documents about glass recipes. So these are on cuneiform tablets. You can see some of these in the museum, Pergamon Museum in Berlin, for example, if you ever get a chance to visit there. But we know the recipes are much older than that. But this is the first written records we have. Now, jump ahead to Roman times, and things change. Okay, so now we're talking about production in the Levant, which is the coast where Israel is, and on the coast of where the Nile is. And now we're using different production techniques. So now glass is not made in little shops and shipped in cakes, but it's made in giant ingots, which is then broken up and shipped all over. And the thought process, by archaeologists is that because they were using natron, which is a very localized source in the Nile Basin, and then all the shops are on the beach because the beach sand is the highest quality sand for glassmaking. Okay. So these then lumps were taken and worked by others, and so. There's also evidence for these, different glass houses along these beaches because we can tell the specific sands because they have different impurities in them. But the natron all comes from one spot. It's also during this time that we have evidence of glass recycling, especially because of some of the decolorants that they were using. Because the natural material comes out aqua like this. because there's a iron impurity. So if you take a pane of window glass, if you know, your window breaks or something, and you hold it up and you look along that direction, it's kind of greenish blue, right? That's because there's a small amount of iron in there, and so it's making the glass that color. So, you know, there's some technology involved in making it colorless. You know, Dr. Meredith talked about the Lycurgus cup, and I'll say a little bit about color in a minute. And then this is really the beginning of glass blowing also. Around 300 BC was when we have the first evidence of this. And really it revolutionized the availability of glass, made it much lower cost, made it much more available to people. Those of you that saw the talk last night, you know, heard Ben talk about how you make flat windows. That was also done in Roman times, where you blow a huge cylinder and you cut it out and you slump it. So they were actually making physical windows even at this time as well. Okay, back to science. So one of the important things that you're going to observe when you see them making glass is that it has different sort of flow properties as a function of temperature. And so at a certain point, you know, they stop being able to work on it and they have to heat it up again. Okay, and that's because it has a certain viscosity. And maybe you have an experience of viscosity because you've tried to pour honey and you've tried to pour water and they pour differently, right? That's what viscosity is. Well, viscosity has a temperature dependence, and glass has some very sort of distinctive transitions in the viscosity where things are important. So for example, you know, the lower the number here is the less viscous, so the more like water. So you have a working point in glass, and that's where you deliver it to a machine. So for example, if you're making beer bottles, you have to heat it up to a certain temperature so that you can drop it in and blow into the mold to make your bottle. Okay. At a slightly higher viscosity or lower temperature, you have the softening point, and glass will deform under its own weight. So when you watch them out there, I want you to see when it's deforming under its own weight. That's the softening point. And then the glass transition is very difficult to explain, and I spend at least 1.5 hours explaining to my class what the glass transition is. But basically, it's where the structure, the non-crystalline structure, is frozen, and in order to change it again, you have to increase the temperature again. The annealing point, you'll see some annealing ovens out there, relieves the stress, but will not change the structure. And then the strain point is below that temperature. If you cool it rapidly, it's not going to crack. Okay? So we heard a little bit about this yesterday. No, cathedral windows do not flow. The fact that it's thicker at the bottom is not because glass is liquid and it's flowing. It's because they blew this big bubble, flattened it out, and cut panes out of the middle, and this little part knob in the middle is where it was attached to the rod. That's called the crown. And so, you know, like a good engineer, the glass people, you know, put the, you know, thick side down. Okay. Slightly more modern thing to recognize is that this is actually very important in how your cell phone is made, because you have multiple pieces of glass in your cell phone, not just the one on the outside. There's ones on the inside that actually have electronics printed on them. And so the glass maker makes a sample or a pane that then he sends to, or she sends to somebody to print the electronics on them, and to put and for that to work, they have to increase the temperature. Increasing the temperature, I change that non-crystalline arrangement, the volume changes, and now these features change distance. Okay, so there is a relaxation that happens, just not at room temperature. And so we have to understand how all this works, or we can't have cell phones. All right, so some of my colleagues at Corning Company do a lot of this kind of thing. Okay, back to history. The sort of last period before we get to modern technology is the Islamic glass industry. really, and this is the medieval times as well. You see, stained glass, just fantastically beautiful vessels, and at this time, which is kind of 800 to 1500, you now have everyone knows how to make glass now. And so you have local sands and local everything. And so you have all these different sites that we can identify where glass is being made. And that's really the third, kind of revolution in glass production in the ancient world, where everyone is doing things locally. And so this is when you start to see glass in Africa and India and places like that as well. In medieval Europe, you start to see stained glass windows, fantastic works of art and lots of new techniques on how you make color, lots of new colorants, and some technology, which I'll show you an example in a minute of how you layer these things. You see more mosaics, and you start to see technology, and one of the differences in Europe is that you're actually now, you don't have natron anymore, so you have to go back to plant ash. And what they use in Europe is actually wood ash. And wood ash has a lot more of the alkali potassium than sodium, which is actually really bad because it's not very chemically durable. And so you have, I think Ben last night was mentioning sick glass. So you have a lot more sick glass. It reacts with water, and it's a conservator's nightmare. And so this wood ash glass is what all of the stained glass is made out of, and other types of objects. Speaking of color, how does glass get its color? So there's three ways that we can get color. The first one is light absorption. And so we can put different metals in glass. So iron, this is iron, this is copper, chromium, nickel. We can also put actual small metal particles. And so gold strike glass is very red, ruby glass. And you also can put small particles of semiconductors. For example, cadmium selenide and cadmium sulfide give specific colors of glass as well through light absorption. And that's how one of the reasons that Lycurgus cup looks the way it does. Then you can have reflection and transmission. So this is a phase-separated glass that has two glasses. And this is why the sky is blue and sunset is red. This scattering phenomenon is called Rayleigh scattering. And you can observe this in a simple phase-separated glass. You can also have light emission. And so the light from the ambient can interact with what's inside the glass and then give off its own light. So this is a uranium glass called Vaseline glass. And under an incandescent bulb, like a tungsten filament, it looks kind of yellow. In the sunlight, it starts to look green, but if you put it in ultraviolet light, it looks very deep green. And that's because it's giving off its own light, because the ultraviolet is interacting with the uranium ions and giving off light. So as scientists, we can actually measure these effects. So this is by a friend of mine, who is a French really scientist who is studying some of these Sainte-Chapelle windows, and has written some very nice papers on how you understand the glass-making technology in these stained glasses, where you have multiple layers. You have a clear glass layer, you have little red glass and green, and so you see, when you look at a window, you don't really think about that. But if you know something about how they made these, it's actually kind of mind-blowing. This is just what we would do in my lab. We would measure how light goes through and measure some of these things about how the color is formed. One thing you may not appreciate is the effect that glass had on technology. So maybe you know now because of cell phones, and I'm almost done. But those of you like me who have poor eyesight, before we had glass lenses, I would probably have been killed by a saber-toothed tiger. But the scholars and a lot of this sort of you know, scholarship in monasteries, etc., copying of manuscripts would not have been possible for many people without eyeglasses. At the same time, once we started to understand optics, we could make microscope lenses. And in fact, I highly recommend that you read this short story by Rudyard Kipling called The Eye of Allah. And it describes how this object that turns out to be a microscope, which was developed by the Islamic scientists, found its way into a monastery, and they started looking at something through this microscope, and they see microorganisms. And they absolutely freak out and think it's the devil's work and just, destroy the microscope and kill each other and stuff because they don't want this to get out to the church. But I don't want to underrepresent the importance of glass for being able to do this, both look small and also look far away in telescopes. This totally changed the worldview in this time. And then this is another fantastic piece that interestingly looks a little bit like some of the things that Ben makes. This is an alembic. It's an actual alchemical reaction vessel that, alchemy was what people called playing with chemicals before it was chemistry. And this is a vessel in the Corning Museum of Glass that, again, enabled the development of chemistry and our understanding of natural science. Today, glass gives us beer bottles. Containers is a huge industry in glass. It gives us windows. We heard a little bit about float glass last night, about how flat glass is made by putting magma on a river of tin, which is crazy when you think about it. Enables our communication. The internet, as I talked about, optical fibers, these are glass fibers. Fiber lasers, so this is some laser glass that enables things like medical treatments and all kinds of industrial processes. Optical components, cell phones we talked about. In healthcare, you need special kind of glass to hold drugs. You actually can make tiny little glass spheres to deliver chemotherapy and other types of things into the body. There's some crazy applications where you think of fiberglass wool as like insulation up in your house, right? Well, we can make glass wool that you can actually pack a wound, and it will increase healing. And so these are realized technologies right now. We can put a little bit of silver in glass and disinfect surfaces, which people got very excited about when our world shut down because of contaminants everywhere. It's also important in energy. We put all of our solar cells on glass, and if that glass didn't have the right properties, we couldn't have solar cells. The fiberglass that we use to make windmills is all glass. These are amazing industrial plants where they make this kind of fiberglass. There's glass-based materials in batteries, all of these sort of fancy windows where you press your cell phone and it gets dark. All that is glass technology. And in the environment, I guess near and dear to my heart and what my group works on a lot is using glass to protect the environment from radioactive waste. And so that's what a lot of my work has been. All that and is still a fantastically, amazingly beautiful material. And so I just, would never have gotten this far without all of these people that I have worked with in the last 10 years, including all the ones on the top who are all WSU students. And I am looking for a few students to work with me in my group. So if you are interested, please talk to me. And I really do hope that glass gives you, and this, maybe something that you learned today from us, gives you a little bit different window on your life. So thank you very much.
So I'll pass this mic around to anyone who has a question for Hallie or John.
Thank you both for your very interesting talks. I have a curiosity about this transition from classical to late antiquity and sort of how this process of glass technology, glass making makes that transition as well. It seems that as the world is becoming Mediterranean, Middle Eastern, maybe a little less interconnected, and going back to these more regional technologies, these more regional practices, how do we really see that sort of manifesting in this sort of transitory period?
That's a great question. I'm trying to think how to compartmentalize the answer. So really, what's changing in the shift from like around, let's say, 300 CE? So around that time, there's so much in flux. The better question, I think, might be what's the same. As you know from other areas of life, religion was the technologies of the book were radically changing. You have Judaism, Christianity kind of establishing themselves in contrast to one another. You then have the foundations for what's going to change radically with Islam and just like, so, and I find this period fascinating because I think periods of transition tell you a lot about what's important to people, but also what they don't understand is changing and morphing and developing. So I don't know, that's a great question. I wish I had a better answer.
So I'll just reiterate one thing, and I'm not sure if you're asking about from sort of the late Bronze Age to the Roman times or the Roman times to after, but certainly between Roman and after, the fact that they were using a centralized source of natron for all their glass, once the empire started breaking apart, they had no access to that anymore. And so they actually had to maybe rediscover, or maybe it was a little bit less preferable. It's more work. If you just have natron, it's just your raw materials right there. If you need plant ash, you actually have to grow the plants or find the plants. You have to then make the ash. And so, they could then do that regionally as well. They didn't have those sort of supply lines back to Egypt that they perhaps had when, it was much more of an empire. And then that same thing would happen, towards the Islamic times as well. Yeah.
Anyone else have a question?
Just as somebody who isn't a scientist or science major, what is it about the atomic structure of glass that allows light to pass through it that, things like crystals and rocks sort of have, but, almost no other materials have?
Well, we can make glass that's black too. So it's really not anything that's inherent about the material. It has to do with all the things I mentioned, mostly absorption of light, and it has to do with the chemistry and the makeup of the material and how the atoms are arranged. So we can make transparent, we can make translucent. So something that we call translucent would be scattering. It scatters light, but yet you still see light through it, as opposed to being opaque, which you don't see any light through it. And then we call something that's colorless and transparent. And you can have that in crystals, you can have that in glass. You cannot have that in metal. And if you want to have that conversation with me, I'll take it offline, but no transparent aluminum, sorry.
And just to follow up, in different locations, you'd have different colored, just the kind of regular color of glass. So regular, I mean, if you don't add anything to it to decolorize it. In the ancient Roman world, you had a kind of a blue-green glass, as was mentioned. But in other parts of the world, because of the local sand and the contents of the sand, the color wouldn't be blue-green, it would be a different shade or different in some way.
Just a question on, was there
these breakthroughs historically, were they willing to share, or were they trying to keep it a secret? Like, were there cases where the Romans didn't want non-Romans to know about this or something?
Yeah, that's a great question. There's stories about so there was the so-called Silk Road, right? The idea that there was all this trade, and obviously there's more than one road. But in the East, you have the silkworm, and the knowledge of how silk was made was kept a secret from the Romans. And then the Romans kept glass blowing and the idea that, the knowledge that it's soda lime and silica, that's how you make glass. They kept that a secret from the East. And so part of the reason, presumably, was to save your export market. If they knew how to make it, then they'd do it themselves, right? They wouldn't buy it from you. So early on in the Shotoin treasury in Japan, for example, before the secret was let loose, emperors had glass, and they had poetry that they wrote to about the glass and how amazing it was, and they really valued it. And then once they found out how it was made, then there, as well as elsewhere, it was the raw material was as worthless as a used match. So yeah, it's very important.
So John, you were talking about how you put different metals into the different glasses to make the different colors, and you said you put gold into the glass to make it red. And I'm just wondering, are we still doing that? Are we putting gold in? I mean, does it make it expensive, or are we just putting like a really tiny amount in? Like, does it? What's going on there?
So for you, Claire, I'll give you the slightly more complicated answer, and that is you have to strike the glass is how glass makers talk about it, and so you reheat it, and what happens is you get nanoparticles of gold, and they're of a specific size, and so the light interacts with the surface of the gold particles in a surface plasmon resonance, which gives you that deep red color. And you can do that with other metals like silver and maybe even copper. It is still done, but again, it's not very much because these are very, very, very small particles. But it's tricky to get it to do it right.
Can I ask a follow-up question? So my follow-up question is, what kind of quantities? Are they so small that like you could just sort of shave a coin, or is it more like you'd need to have a supplier?
I think you could use a very small amount. We haven't done it in our lab. We've tried it with silver and to some modest success, but we're actually thinking about trying it with gold too. So I could give you but I think it doesn't take very much, but you have to know exactly how to do it right.
I was just wondering about the evolution of glass and how you feel we are in that state now. Do you feel we have reached a stagnancy, or what do you think the future holds for glass blowing?
What does the future hold? I think that's, again, a really great question. I don't know. I'm not certain how to answer it. Personally, I think maybe because of the context of my book that I'm working on, I think that the past really informs the present. And one thing that I think is really important is thinking about how we learn. And so part of what I'm interested in is the anonymous maker. So somebody whose name doesn't survive, we don't know who they are, but we can work out something about them through what they made and traces. So whether it's interrupted making, that we've got vestiges of broken pieces, or like lots of replicated versions of something. But one thing that I think is really important is this idea of embodied learning. So we learn things, and we learn in so many ways that we're not conscious of. Sometimes you're conscious of movements. And one thing that I had when I was learning to blow glass is an instructor had certain movements, and it was like like dancing. So their arms, you have this back and forth with a blowpipe, and you need, because it's when glass is hot, it's viscous like honey, as was mentioned. And so if you stop moving it, it just falls off. And so you're constantly centering it, but you do it sideways. And so you often have this bench with two arms, and so you can go back and forth, and it holds the pipe, right? And so my professor, he would have this beautiful, graceful movement with his shoulders. And one day, somebody, as a joke, they held his shoulders, right? So he couldn't do that, and he like, you could see the pipe stuttering, and he couldn't do it the same way because he didn't think about it. It was an embodied kind of somatic version of learning that with his body that was how he did it. And so I think that there's something about the knowledge that we have that's physicalized, that's more than just thinking, that you do without thinking, that is really important, that again is part of what we do as students or scholars. But when you see glass blowing, or you see any art form where you have these people who are trained and do this as a career, they've got years of experience and they've worked in different ways and practiced in different cultures and countries, I think there's something really, really profound there that you can also learn from. So I think it's not necessarily just about one technology, but maybe it's broader than that. That would be my.
I'll just add one thing. And initially, I thought your question was going in one direction, then you specifically asked about glass blowing. But if the question was about what is glass going to do for us next, I would say that I'm sure there's going to be something that we can't even imagine, because 100 years ago we learned how to float magma on liquid metal and make, float glass. And then, 50 years ago we learned how to draw glass fiber and create the internet. In another 50 years, I have no idea. But the amazing thing about glass is the fact that you can make it in a certain way. It has properties that, to Dr. Meredith's point, I make all my students actually make it, because there's a sense of how it behaves that enables you to do certain things with it in technology that you can't do with other things. And so the properties that it has allows you to have certain kinds of applications, like drawing fibers, right? Which we can do that with other materials, but it's much, much more difficult, and it's not nearly as effective. And so I guess that's what I would say, is that by understanding the material itself, and then maybe knowing a little bit about how to manipulate it, whether it be as an artist or as a scientist, we're going to come up with some things that we can't even imagine right now.
Is this working? Yeah. I know there are a few more questions, but we are a little over time, and we need to transition we're going to transition some of these chairs outside near the glass. The glass blowing demonstrations will be occurring between 2 and 4, and 4:30 and 6:30. So we really encourage you to stay or come back, and hopefully you can interact a bit with Dr. Meredith and Dr. McCloy, for the rest of the day if you had more questions. Thank you, everyone, for being here for these talks today. Karen Weatherman is standing at the back. She is the director of the Common Reading Program. And if you are here for that, I think she might want to see you. There's also a QR code over here on this table for today. Yeah, we're going to bring that outside now, Karen. So if you're here for Common Reading, please see Karen. And thank you all for being here.